Okay, good afternoon, good evening. This is Miss Cable, and I want to do a video over distance between two given points. So my points I have given is 4, -7, and -4, -6. So what I want us to do first is put it on a graph so that we can see what it would look like. What I have done is drawn out a quick sketch of my graph. I labeled my axes, X and Y, and then I drew kind of an estimate of where those points should be. So what I'm trying to figure out is the length or the distance between +4, -7, and -4, -6. So what we will use is the distance equation. Give me a second to write that down. So the distance equation is given. It is the square root of x2 minus x1 plus y2 minus y1, and we squared that as well. So what I want to do first is label everything that I have given. So 4 can be x1, and the -7 can be y1, while -4 here is going to be x2, and -6 is going to be my y2. Okay, so now I'm going to plug those points and those values into the equation. So if I start with my distance equation is equal to the square root of -4 minus 4 squared. That minus comes from the equation. That's what's given. I didn't change anything. This is the -4 here, and then this is my -4 there. Okay, plus, now you take a second and say what should come next. Hopefully you had a -6 minus a -7 squared. And excuse that because it kind of ran together, but we talked about this in class and a couple of times. A minus a negative is nothing more. It kind of looks like a sleeping person there, and when you're sleeping, you're happy. So minus a negative can be rewritten as a plus sign. So all I want to do now is just rewrite the entire equation. Took a second to look at that to come up with the exact same thing that you see here. So a -4, now I'm just going to simplify because PEMDAS, I have to go with parentheses first. So I want to start off by using a -4 minus 4, and that's the same thing as me borrowing $4 from you and borrowing 4 more. Altogether, I owe you $8, and so we would have a -8 squared. Okay, plus this -6 plus 7, you can rewrite it as 7 minus 6, or go with the rule that if the signs are different, you subtract and take the sign of the largest number. So in this case, with -6 plus 7, you're just going to get a +1. Okay, and that 2 is also squared. So my distance is going to now be the square root of a -8 squared plus 1 squared. And I want to expand this in a second to show you what's actually happening with those squares. As this is a video, I'm going to do the extra step just to make sure that we understand when we're squaring a number that we're actually multiplying it by itself. And according to the rule for integers, if I'm multiplying a negative times a negative, I will automatically get a positive number. So this is going to become a +64, since 8 times 8 is 64. And then 1 times 1, I hope you know is 1. So we're going to add 64 plus 1, and we're still going to take the square root. I write it out, you write it out. Okay, so from this point on, I can't do anything with parentheses. There's no more exponents. I've already multiplied, and so all I have left to do is find the sum. So I'm just going to add the square root of 64 and 1 added together is going to be the square root of 65. Okay, now if I take it a step further, I can simplify the square root of 65. It should be somewhere about, and that symbol just means around. It's kind of like an estimate, but it should be like 8 point something, 8.0 something. But I'm going to just make sure. Okay, so the square root of 65 is 8 something. I'm just playing. All right, so the square root of 65 is 8.0 6, I'm okay with 8.1. That's all right. All right. Now, once we figure out what our distance is, and remember, we've been leaving it as a square root in class due to the calculator thing, but hopefully we'll get those out to you by Monday. So the square root of 65 or the approximate answer of 8.1 will suffice for the length of this line. Now, I want to take it just one more step further. When we are looking at the length, and this is how we started it in class, we look at what our movements are. So I'm going back by my graph. And so what I want to do is draw a little right triangle. Okay. Now y'all know Miss Gable can't draw straight lines. Okay. But right in here, I would have a right triangle. So I would look at what the movements would be. Now, if I start down at a -7, and I'm just looking at the y values, from a -7 to a -6. So if I move from a -7 to a -6, that's just a movement of 1. Okay. If we go from a +4 to a -4, so I'm going from a +4 to a -4, I know I got to go through the origin as 0. So I'm going from 4 to 0, then from 0 to 4. So for that reason, we would move 8 times. Now, when we talk about the reasonableness of our answers, what you should know about right triangles is that the diagonal or the slanted side, the side that's opposite the right angle, and we'll go into detail about that later, it has to be the longest side. So just knowing that the hypotenuse, which is this longest side here, that's the name for it, is hypotenuse, is 8.1. That lets me know that the distance that I found is correct. All right. So here's what I got for you. That's distance. If you're still struggling with it, I want to see you in tutoring Monday or Thursday after school. Have a good night. Ms. Gable loves you, and I look forward to seeing you tomorrow.